Welcome back. We have finished the basic rectifier idea. Now we start a new diode application, clipping. A clipper circuit removes or clips part of a waveform. The diode is used like an automatic switch. When it is forward biased, it turns on and lets current flow. When it is reverse biased, it turns off and the branch becomes open. In this lesson, we use the simplest version, the series clipper. Series means the diode is in series with the load resistor. Our analysis method is always the same. First, choose the input half cycle. Is Vi positive or negative? Second, decide whether the diode is on or off. Third, replace the ideal diode with a short circuit when it is on or an open circuit when it is off. Then compute the output voltage VO across the resistor. Today we will compare two orientations, the positive series clipper and the negative series clipper. Here is variation 1, the positive series simple clipper. The name can feel backwards at first, so keep the rule in mind. A positive clipper clips the positive half cycle. Look at the diode direction. When the input Vi is positive, the diode is reverse biased. It is off, so the series path is open. That means the current is 0. If I equals 0, then the resistor voltage is VO equals I times R, which is 0 volts. So the positive half cycle does not appear at the output. Now flip the input. When Vi is negative, the diode is forward biased. It turns on and behaves like a short circuit. The load is now connected to the source, so the output follows the negative input. For an ideal diode, VO equals Vi during the negative half cycle. So this circuit passes the negative half and clips the positive half to 0. The waveform makes the result obvious. The dashed sine wave is the input. For the positive portions of the sine, the diode is off, so the output is forced to 0. For the negative portions, the diode is on, so the output copies the input. Written as a simple ideal rule, when Vi is greater than 0, VO equals 0. When Vi is less than 0, VO equals Vi. At the zero crossings, the ideal model changes state instantly. In a real silicon diode, the transition is not perfectly sharp, and the forward drop is about 0.7 volts. But for the ideal clipper model, the clipping level is exactly 0 volts. That is why this first pair is called simple clippers. Now reverse the diode. This gives variation 2, the negative series simple clipper. The circuit is almost the same, but the diode orientation is flipped. When Vi is positive, the diode is forward biased. It turns on, the source is connected to the resistor, and the output follows the positive input. So for Vi greater than 0, VO equals Vi. When Vi becomes negative, the diode becomes reverse biased. It turns off and opens the series path. The current becomes 0 and therefore VO equals I times R equals 0 volts. So the negative half cycle is removed. That is the naming rule again. A negative clipper clips the negative half cycle. It passes the positive half and forces the negative half to 0. Put the two circuits side by side and the pattern is simple. In a positive series clipper, the positive half is blocked and the negative half passes. In a negative series clipper, the negative half is blocked and the positive half passes. The only difference is the diode orientation. Everything else is the same. One diode, one resistor, and the output measured across the resistor. This is also a useful way to analyze any diode waveform circuit. Do not memorize every drawing. Instead, ask which half cycle makes the diode forward biased. That half cycle can pass through the series path. The other half cycle leaves the diode off, current equal to 0, and the resistor output equal to 0. For simple ideal series clippers, the clipping level is 0 volts. Let us recap. A clipper removes part of a waveform. A series clipper puts the diode in series with the load resistor. If the diode is on, the load sees the source and the selected half-cycle passes. If the diode is off, the path is open, current is 0, and the output across the resistor is 0. The positive series clipper clips the positive half and passes the negative half. The negative series clipper clips the negative half and passes the positive half. These are simple clippers because the clipping level is 0 volts. Next, we will add a DC source in series with the diode. That biased clipper lets us move the clipping level above or below 0. See you in the next lesson.